I'm Mr. Hildreth, for those of you who don't know me. The kind of purpose of this course here is just to try to introduce you to the main concepts and some strategies to work with those problems that are likely to be covered. Again, this digital form of the SAT, the very first time it's ever been run was on March. So you guys, if you're taking it here this upcoming weekend, you are in the only the second one to have to be done digitally here in the U.S. They've done them internationally for a while. There's a packet right here on the end table if you want to grab that. So the whole idea here is a couple things to get you familiar. Let me talk about the website first. So I believe everyone here has confirmed the Canvas course or the invitation for that. If not, go in and do it, or if you haven't gotten an invitation, contact me or let me know. The main page or the front page of this Canvas site or course has everything, it's all the links that you could use are on here. So if you want to do these notes from this packet on your iPad, you can load right here. This is the full-size notes, so they're not kind of condensed where it's like 2 per page. If you want to do them on your iPad, you can just load them here and follow along as we go through them. If you want to use the paper packet, you can. The idea for this course here is we're going to go through mostly the even questions. There occasionally we'll do like an odd one if it has like a concept that I want to cover. But for the most part, we're going to go through the even questions on this packet. So as you go through them, Rowan, there's a packet for you right here. As you go through them, on the very last page is an answer key. And so, if we're working through, and let's say I give you, I ask you, answer this question number 2. If you want to do any other odd questions, while you're waiting, you're welcome to do that. Check your answers on the back and so on. The odd questions are what I kind of do in the March course. And so I have video captures of me going through this whole same course here for the odd problems. And then I'll post video captures of what I do during this course over here on the right side, and it'll say the even problems. What that means is I know, especially tomorrow, so tomorrow we don't meet in the morning because of just the Tuesday schedule, and I have a meeting before. So we'll meet after school tomorrow. If it interferes with your activities, I'll post a video of what I do. If you're here, we'll go through it, but if you're not, I'll post a video, and again, you're welcome to look at either one, the one from the odd numbered questions or the one that we do this week with the even questions. But that'll all be posted here on the Canvas page. If you continue to scroll down, basically the links on the left are my links. So these are questions that are I've copied down the questions that I've had access to, and I put them in a digital format that can change. Every time you take it, it's a different set of numbers, a different combination of questions. So anything that you click over here is going to be new every time you do it. Okay, so these are all the left side is the things that I've created. On the right side, these are the things that have been made available to you guys from the College Board. Okay, so these are the practice tests that they've made available for you. If you keep going down, you are going to bring your own device, and you're going to take the digital test on your own device. So if you've signed up, they should have probably contacted you with information about that. You can take an iPad, you can take a laptop or whatever, but it does require you to have what's called Bluebook app. So I would encourage you to load that first. This app has some practice tests on it too, and it gets you familiar with everything that you see on the what the app actually looks like, and it's useful to take a look at that. And then the Khan Academy prep, again, this has always been questions that were based on their very initial concepts. Once they start doing the test, they change the concepts a little bit. So I mean, when I've looked at this, I mean, it gives you some content area, but it's not always as specific to the types of questions that you're going to see. And so this right here, if you keep scrolling down, the stuff below here really doesn't have, or this is the stuff that just kind of talks. These are the concept areas that are covered in each of the 4 content It has algebra, basically algebra 2, geometry and trig, and then just problem solving and data analysis. That's kind of the topics that they break it down. Okay, there is a calculator that you're allowed to use during this test. It's built in, it pops out if you call for it. And so I will go over a couple things on how to use Desmos that maybe aren't quite as intuitive, but they're there. Definitely use it and get familiar with it. Like one of the best things you can do is to practice using this calculator. So this is embedded right here, but if you click this link, it'll open in a new tab if you want the full size view. And then go into that app, the Blue Book app that they use. It actually shows you what it's going to look like. It's slightly different than this. It's not that different. It still has most of these same tools. But you can see right here, they have multiple versions of them. This is the one, this is the version, or it will link to the version that is going to be embedded on the SAT for you guys. And then this is just the reference information. Again, there's a call out button to bring this up on every page of the math sections in the digital test itself. And so just being familiar, these are the things that you don't have to memorize, although most of you will probably be familiar with them. But this is the reference stuff that's included. Okay? So that's what the Canvas page looks like. Again, what I would encourage you to do is these right here are just practice versions of everything. If you just want to take a practice version of each of the sort of sections, I would do these two links right here where it says full-length digital practice. I've tried to balance it with like a similar percentage of content as well on those. Okay. The last thing to kind of discuss is the way that the SAT works now. Okay, is you have 35 minutes to answer 22 questions. Okay, and there's just, they call it module 1, so whatever the first section is. And then based on how you do on that, you're either going to be given a second module that's easier or the harder one. I mean, I think from what I've seen, there's just 2 versions of it. And so it's adaptive in that sense. You can go ahead and grab a packet. There's a packet there on the edge of the table. Okay, so if you do well on the first section, it'll give you like a harder version on the second. If you don't do quite as well, it'll give you a slightly easier version. And I don't know how they've scored it yet. I haven't really, like they haven't shared much about that. But obviously you want to get to the harder section if you want the higher scores. Okay, so but that's there is a variability, and so like if you see like some of these right here, somewhere up here, I have something where right here. So it has the practice test, the hard version. For these, I have the easy version here if you want to see what the difference in the types of questions are likely to be. Okay? But the content area for those are approximately the same. If you have any questions on either the way that this Canvas page is set up or any of the course material, or if you have questions on other material that you're prepping with, please feel free to come in. I'm in this room at any time, so during break, during flex period, before or after school, possibly you can find me in here, lunch too. If you have any questions, you can come find me, ask me, you can email me. And then also, if you click on any of these practice tests here, it's going to open it up in what's My Open Math. I mean, most of you have probably been exposed to it a little bit in here, but there's a message system. For every single question on these practice tests, you can contact me directly, and then I will write you back in that. If I write you back, it's going to show up right up here. You're going to have like a little, right here, a little envelope it'll like kind of, anytime you go into any of these any of these practice problems, this will have a little number circled in red, and that tells you I've replied to that the message. But you can send me a message if you have a question. The advantage to sending a message through this message system is it actually it links to the question that you are on. So if you have a question specifically about this problem and you click here, it embeds your version of the problem in my message so I can see what you did, and then I have access to links to go to see what your answers were, and so I can see it more clearly for that. All right, any questions just about the site itself? And you guys have access to this like for the rest of while you're here in high school. Same with access to asking me questions. And so next year, if you guys are taking this again, like the senior fall, you can come in and ask me, and I'm happy to answer any questions you have, and you have access to this material. All right, so that's the digital resources that are available to you. Okay, again, going back to this packet really quickly, the front page just has the material here, or the content area broken down. And so this is what this content area is the approximate percentages that each of those topics is going to be covered in the questions. And so let's take a look at those real quickly. Okay, so the focus should be on Algebra 1 and Algebra 2. Okay, those are the two things that are closer to 30% of it. So together they're about 2/3 of the test. And then you have the problem solving, which is mostly being able to look at charts and graphs and different representations of data. And then also, lastly, you have some geometry and trig. It's a little more like focused. So when we go through that material, I'll highlight the things that you should know. For the most part, this course will get through these two topics completely, like through what I want to cover. And then we'll kind of cherry pick different concepts from these two with whatever time we have left. Okay? And if you do have any questions at any point, please let me know. And if you want to meet afterward to ask questions, I'm happy to go over those. All right, so let's start with the concepts from algebra that you need to be familiar with. So if we look at this first set of slides here, what you're going to see on these is, like, up in the top right of a slide, if there's a set of notes that kind of correspond to the material, I've put those notes up there at the top. But for the most part, I'm just going to kind of have you try a problem, and then I'll talk through the strategy of solving it. And like I said, we're going to go through the even questions for this, but you can do odd problems if you're waiting, and there's video captures for the odd problems on that Canvas page. So I want you to try this question number 2 here really quickly. This is the first concept has to do with solving linear equations with one variable. And I just want to talk through a few of the strategies specific to SAT especially. All right, so while you work, sometimes I'll just start talking about sort of the background of stuff, and then I'll go through the problem. But if you are looking at a question where there's only one variable, and they ask you to solve for an expression that isn't just saying find x or find y, there's a very specific strategy that SAT has used for a while. This isn't the first time they've used it. But if you see, if it's asking you to find an expression, more than likely there's some direct way for you to find that expression. Morning. Go ahead and grab a packet from the table, and you can grab it and open a seat. Okay, so if this problem is asking you to solve for 14x minus 1, what you want to do is you want to look at the problem. Rather than solve for x and then plugging that x in, just look at the problem and see, what can I do directly to this problem so that I create this form 14x minus 1? Well, that would be multiplying everything by 7, right? If I multiplied that first expression by 7, I'd get my 14x minus 1. So if I just distribute this 7 through, I get 14x minus 1 equals -4 times 7, which is -28. Therefore, I find my answer directly. Okay? And so this is a very consistent strategy for the SAT. You don't always have to solve for x. Just try to solve for the expression you see. So just really quickly, if you look at the problem up above, you want to solve for x plus 4. Rather than find x and then plug it in, what you can do is just directly combine these. So if I just subtract this whole set right here, subtract 4x plus 4s, I'm going to be left with 1x plus 4 on the left, and I'm going to be left with 30 on the right. And so you can see that it directly leads you to the answer. You don't actually have to find what the variable is. Okay? So now, there will be times that they ask you to find x, and you do, but if the solution, or if the problem says find this expression, look to see if you can create that expression directly. All right. In addition to those types of equations, you do need to just be familiar with the problems where there's one solution, no solutions, or infinitely many solutions. So again, no solution, what happens is that all of the variables cancel out, and the constants that are left aren't the same. So you might have something like 5 is equal to -3. That's not a true statement, so there's no solution. You may also have one where everything cancels out and you're left with the same thing on each side. So you might have -3 is equal to -3 or 0 equals 0. If that's the case, then there's infinitely many solutions. Okay, so based on that, again, see if you can answer this even question number 4 using that similar concept. All right, so no solution means that you're going to get different constants on each side of the equation. So the fact that there's only one variable in here means that variable needs to cancel out. So if you're familiar with that, then you know that the only way you can get rid of that x is if the coefficient is a 0. So looking at that, you know that b has to be 3. The only way to cancel that is if b is equal to 3. Okay? Now, what I want to do is I want to show you how you can use Desmos. Okay, so on the Desmos calculator, there's 2 features on this that I strongly encourage you to get familiar with. It will help you tremendously. One is this add symbol, and you can create a table and do some regression like equations. I'll show you how to do that a little bit later. This problem kind of indicates the other one. The other one is if there's a variable in your problem, especially one that represents a constant, so not one like an x or a y that you're solving for, but if there's a variable, Desmos allows you to create a slider, and you can basically test every answer option. So I'm going to write 2 equations here. So I don't need the y equals here, but I'm going to put it. So I make that align with b being a slider that I can adjust, and I want to see where that is equal to 12. So when I look at this slider, what I can do is I can find, if I set both sides of the equation, my solution on this would be where they intersect, right? Well, if I start looking at that slider here, it has no solution. So in order for this to have no solution, the lines would need to be parallel to each other, correct? So if I adjust this slider until my lines have no solution, meaning they're parallel, I can see exactly the only point where that works is 3. Now, if I don't want to use the slider to test all points, I just need to test these 4. So I can just go into this slider and test 7. Do those intersect? Yes. So that can't be 7. Test 4. Do those 2 lines intersect? Yes. Test 3. Do those lines intersect? No. I can do the last one. Test 1. Do those lines intersect? Yes. So I can see that the only one that works on that would be 3. Okay? So you can use the slider and the fact that both sides of the equation need to intersect to give you a solution to help gauge different questions. All right, continue with this. There's also going to be modeling involving a single variable. Just realize that the slope is the coefficient of the x term, and that's the rate of change. Right? And then the y-intercept is going to be the initial amount. Okay? But see if you can answer this question 6 here based on the given problem. So even though this is an algebra type of problem, it does sort of incorporate some geometry, and using rectangles and squares are the most likely type of geometry. Figures involving perimeters and areas. And so if you have this dance floor with a width of w feet and a length that's 9 feet longer than its width, so w plus 9, and what you can then see is which of the following is their perimeter. And so perimeter is just the sum of all of these. And so if you took w plus 9, and there's 2 of each of these, right? You can either put coefficient in front of those, or you can physically combine them. And so here you get 1, 2, 3, 4 w's. You get 9 plus 9, which is 18. And so that would be your solution. Okay. Again, pretty relatively simple, but the Algebra 1 concepts that are covered here are going to be like this type of problem. continuing looking at this, and see if you can answer this question here, please. So some of the or most of the questions are multiple choice with an option of 4. And there are other questions where you fill in the correct answer. Again, if you ever prepped for the previous version of SAT, the answer for these student-produced responses, that they call them, were more limited than they are now. Now, because it's a free response entry, you can have negative numbers, you can have fractions, decimals. But before they didn't allow negative values. But so if you get a negative answer, that is fine. You can enter negatives now. All right, how many of you distributed these combined like terms and solved for P? Okay, that's kind of how we've all been trained to do it, right? So if you do it that way, and I'm not saying it's wrong, okay, just keep track of how long it takes you to do like different styles of solving. So if you distributed the 2 here, you get 2p plus 2, distribute the 11, 11p minus 11, and equals 4p. You would then combine all of your like terms. So if I subtract 4p from both sides, 2 minus 11 is a negative 9, so I'll add 9 to both sides. And that's going to give me, here I have 7 plus 2 is 9p. On the left, I have a positive 9. Divide both sides by 9. I get p is equal to 1. So again, I have like a good level of certainty. I did that right. But I also want to show you, you have access to this calculator. It's not a TI-89, although you can take your TI-89 with you as well. So if you're more comfortable using a TI-89, you can. Okay? But with Desmos right here, just know if you are using Desmos for something where you want it to solve, use X's or Y's. Okay? X's preferably. Okay? So if I were to replace the P's with an X in this, and I just solve, there's a couple different ways you can work to solve. One is if you just set the equation exactly as it is, okay, it's likely to give you a vertical line at the solution. So there's our answer, 1. Okay, the other way that you can do this, if that doesn't work, or if you can't see exactly, like if it's a decimal value and you can't really see where it intersects, what you could do is what I did on that last example. I can do a different line for each side of my equation. So here I could have put this, just started with the left side of the equation and then put 4x. Remember, put them all in terms of x's. And then you can see as a system where these intersect. And that intersection, the x coordinate is your answer. So that would also show you that your answer is 1. Okay? And so, as I mentioned, even though, like, I have no doubt that everyone can do this, like, solution method, if you understand how the calculator works, all I had to do was change the p to an x, and it gave me and type in exactly what it showed, and I got my answer with a higher level of certainty because it's a calculator. Okay? So get familiar with the calculator. It's very likely to help you in these types of problems. All right, next content area here is looking at linear equations that have 2 variables. Now, sometimes they'll have an x and a y that are kind of in that general form where you have the ax plus by equals c kind of form. But a lot of times in the modeling, it's just going to be 2 different variables. Oftentimes the variables will start with the same letter of what they represent, okay? And then the coefficients just represent sort of the unit value of each of those. So when you look at a problem like this here, even the one up above, 3x's plus 32y's equals this total. And so for this, it's a matter of interpreting what does the coefficient represent. Up here, you can kind of see it's the area of each of those items. And so here you would see that the x is the number of parks, the y's are the number of residential areas. And see if you can kind of apply that to this question number 10 here, and see if you can find out how many more points a red token's worth than a green token. So again, as you think of this, it's 8g plus 42r equals a total number of points of 330. Right? And so if G represents the number of green tokens, R represents the number of red tokens, what are the coefficients they're representing? It's the point value for each of those tokens, right? So here you see that each red token is worth 42 points. Each green token is worth 8 points. This question is simply asking you how many more points is the red one worth. So you're just finding that difference. Okay? So it's probably you were trying to read more into it. You don't have to find what G is. You don't need to know what R is. You don't have to find combinations of those. You're simply solving the difference between those, and that would be 34 points. And so again, be aware of what the coefficients represent in the linear problems that have the two different variables. Right, sometimes, as we're probably more familiar with, the equations with two variables are linear equations, right? They're just different forms of linear equations, the general form of it. And so you can always rewrite it in the form of y equals mx plus b if you need to find information. But if you're looking for x or y intercepts, remember that the general form allows you like an easy way to find that, right? ax plus by equals c. If you just let the x value be 0, then you can find what the solve for y. That gives you the y-intercept. If you let the y be 0 and solve for x, that gives you your x-intercept. So if you're finding the intercept, sometimes it's easier just to use that general form anyway. All right, so see if you can answer question 12 here before I talk through it. All right, so a couple different ways that you can approach this, both mathematically and visually. Okay, so for me, since the translation down means that you're taking a graph and you're shifting it, what I would do is I would first put this in slope-intercept form. So I would solve for y first. So if I'm solving for y here, I'm going to leave my 2x, move the 13 over. I'm going to move the 6y over, and I moved it to that side just so I could work with a positive number. You could have moved everything. You could have switched it and moved it to the other sides. I'm then going to divide everything by 6. And so if I'm looking at this, here is my, so when I look at this value right here, and I want to find that, I'm simply going to type it in Desmos. Again, Desmos is a graphing calculator. So if you type that in, 1/3 x minus 13 over 6, I can see right here where my x-intercept is. Okay, so my x-intercept for this is 6.5. I could solve it by plugging in the 0 there for the y and solving it as well. But here, this gives me my answer. Well, I'm shifting this down. I haven't accounted for that yet, so I need to move this down. Okay, so if I move this down, I'm just going to go up to my graph, and I'm going to physically add a -10 to it. And what that allows me now to do is go right to my graph here and see what is this answer. My new x-intercept is 36.5. And so that would be my answer. Okay. Take advantage of the calculator. Okay. It does a lot. It's just a matter of getting familiar with a few things that you can do. But again, making sure that you're using x's and y's is one of the main things. And then, again, rely on that slider and be able to do the regression equations that we'll talk about here a little bit later. All right, keeping with the linear equations, here I want you to see if you can answer problem 14. So one of the other features of the digital platform is there is going to be sort of a little button on the side that allows you to eliminate answer choices. Okay? And in the SAT, eliminating answers that are not correct is part of the strategies for solving questions especially as it comes to ones that get a little bit harder for you, or if you can't really distinguish what it's asking you for. A lot of times you can, at the very least, eliminate one or two of the options. So right now, again, you have this 25% chance of guessing correctly. But if you can eliminate one of those, then it bumps up to 33% chance. If you can eliminate two of those, it bumps up to 50% chance of guessing correctly. So eliminating questions, not a bad strategy. And again, because of that, there's a built-in button on that app that you can eliminate. So if you look at this right here, what you're seeing is that you're taking some function and you're translating it or shifting it 20 units. Now, with linear functions, that you can either think of that as a horizontal or vertical shift. I think of it as a vertical shift. It's easier for me to think that way. Okay, and so looking at this, what I know is that the graph of this line itself can't be the solution. So here's a y-intercept of 4. You know that can't, this is the equation of the line they show you, not the one before this transformation. All right, well, let's look and see. So if this transformation is taking some graph and it's shifting it up 20 units, then what do you know about the y-intercept? Is it going to be positive or negative? If it's getting shifted up 20 units and landing on 4, you know that your y-intercept has to be negative, right? So the only possible ones to consider would be the one that is negative, and that is your correct answer. It eliminates all the other choices. So just by process of elimination, you could solve this question. Okay? Even if you're not really sure what it's asking or what you have to find to get this problem. But this would allow you to eliminate your choices. Now, if you are just using that shifting, what you can do is know that the result has to be the opposite of this, right? So we're shifting something up 20 units. That means it has to start down below, 20 units below this. So if you shift down 20 units from 4, you get your new y-intercept, and it confirms negative 16 would be your answer. All right, let's do one more question here, and then we'll break for the day. Okay, so again, continuing with this concept of linear equations, just a reminder that the slope is the difference of y's over difference of x's, and then the y equals mx plus b is your equation for that line. Let's see if you can answer question 16. So the ideal way to solve this is probably by hand. I'm going to show you how you can use Desmos because it's possible that either you don't really know where to go from here, and I can show you that Desmos will allow you to find it. Okay, but if you can do this by hand, that would be the ideal thing. So on this one, we would look to get rid of our grouping symbols. So distribute the 1/5. So we would get y is equal to 31/5 x plus 29/5. And then that's all plus 2x. Well, instead of writing 2 in terms of just the constant 2, let's put it in terms of this same fraction form. So 2 is how many fifths? 10/5. And so when we combine our x's here, we get 41/5 x plus 29/5. The slope is the coefficient of x, and so we get 41/5 for our answer. Now, that would be the ideal way to solve this. And let me show you just again, because it allows me to introduce the other feature of the Desmos calculator that I think is important to learn. Okay? If you're not quite sure how to do this, what we could do is we could create a table of values. All you need is 2 values for linear regression, right? You need one more value than the power of what you're testing. So you need 3 values for quadratic regression. But if we could create a table of values using this given equation, and then find the equation of that table, it would give us the answer in slope-intercept form. So I'm going to show you how to do that. So the first thing would be, if you want to evaluate a function, just use function notation. So I'm going to call this f of x, and I'm just going to type the exact equation as they give me. Okay? I don't have to combine anything or simplify anything. And then all plus 2x. All right, so there is my equation. If I wanted to, I could zoom out here and find the graph of it as well, right? Again, there's my graph. I'm not using the graph really. All right, so the next thing what you can do to set up what's called linear regression is hit this add item and create a table. You just need 2 values. So if you just take any 2 values of x, and you don't even need to physically evaluate it, just call it f of 0, and it evaluates it for you, and then take any other point, 1, and then f of 1. Super easy. It doesn't matter what this is. It adapts to that anyway. And you don't have to actually do any calculations yourself. Okay? And then once you create that table, you can use this format of linear regression. And it's unique to Desmos. They don't teach, or it doesn't, there's nothing intuitive about how it is. So this is the thing that you need to know. If you want to create a regression equation, you have to call it y1. Okay? You have to use y sub 1, but if you just type y and then 1, it'll automatically do that for you. Then you use instead of equal sign, you use similar to. And then you just type in the equation that you want to represent. So for a linear equation, it's mx1. Make sure you use the subscript 1 plus b. And notice it tells you here what your slope and your y-intercept are. Okay, so my answer right here is 8.2. 41/5 is 8.2. I could have put my answer as 8.2. If you feel more comfortable in writing fractions, you can verify that here, because if I just type the letter m represents my slope. Notice it pulls up 8.2, but it also has this little fraction format. If I hit this button right here, it'll give me my answer as a fraction, and I see that it confirms 41/5 as my answer. So you can use the Desmos features to do a lot of things that, again, it's only if you kind of understand like the formatting of them, and you don't know it until you've been exposed to it or looked it up. Okay, but using regression equations is a huge advantage in this using Desmos for all of this stuff. Okay?